Okay, so welcome back. Now we're going to deal with cosecant functions. So looking at this cosecant function here, we have negative 3 cosecant 4x, so we've got our a and b. Okay, so immediately we know a is equal to 3, right? A is equal to negative 3. Okay? Or the absolute value of a is equal to 3, right? It's negative, so it's going to be a reflection across the x-axis. Okay, so we'll have to keep that in mind too. So this is reflected across x-axis. B is equal to 4. Okay, so that means, well, what's the period, right? Well, the period is, now this is cosecant, which is the reciprocal of sine, right? So this is going to have a period of 2 pi, right? So the period, period's always the same. So it's going to be 2 pi over the absolute value of b. I was thinking about the asymptotes and the phase shifts. Okay, so p is 2 pi over the absolute value of b. So again, what's b? B is 4 in this case. So this is going to be 2 pi over 4, which gives us pi over 2 is, well, the period. Okay? Okay, so now, the phase shift. Okay? Well, in this case, because we have no B or C, there's no phase shift. So again, that makes sense because there's no, we're not subtracting a constant from inside the function or adding or subtracting constant, so there's no horizontal shift, right? So the phase, there's no phase shift. Okay? Because C is 0. And remember, the phase shift is C over B. Okay, so let's sketch this thing, right? So we've got everything we need to sketch it. So we have a period of pi over 2. Okay, so where are the asymptotes located? So remember the formula for the asymptotes. So where do the asymptotes happen? Well, remember, this is 1 over sine, so where is this undefined at? Well, it's defined at 0, right? 0, pi, and so on, right? So let's put in our asymptotes. Okay? But when this is pi, okay, sine is 0 at 0, pi, and so on. But when is this 0? So when the argument is 0. Okay, so again, because this is a period of pi over 2 now, okay, well, what does that mean? It means that this is going to be 0 when x is, what? Well, when x is 0. So it's going to have, we're going to have an asymptote here. Okay, good. And where's the next asymptote going to be at? Well, when this is pi. Well, when is this going to be pi? When this is pi over 4. Okay? Because when x is pi over 4, you get pi. So that tells me how I'm going to want to set up my my x-axis. So let's see, we're starting at 0. And let's go up by eighths. So this is going to be pi over 8. This is going to be pi over 4. 3 pi over 8. Pi over 2. 5 pi over 8. And 3 pi over 4. And then this will be negative pi over 8, negative pi over 4, negative 3 pi over 8, negative pi over 2, negative 5 pi over 8, and negative 3 pi over 4. Oops. 3 pi over 4. And so, where is the asymptotes located? So the vertical asymptotes, okay? Those are going to be located whenever this argument is 0. So that's going to be at 0. Pi over 4, and then again this is going to be any multiple of that, right? So then the next one would be pi over 2, and so on. Okay, so let's do that. So I've got 0, so the next one is pi over 4. And then pi over 2. And then, of course, you know, since you know the pattern now we can just go the other way. And so we know we have 1 here, right, and so on. And again, I'm only going to do 1 period, but now we know what does happen. Now again, because this is a reciprocal of sine, we can use the sine function to help us. So the sine goes through the x-axis at the intercepts, right? But it goes through here, but it goes up. So this is going above. So A tells us that it's 3. So A tells us that the amplitude of the corresponding or related sine function is going to be at 3. So here at pi over 8 is going to be where the maximum of this is. So that means the minimum of our cosecant function is going to be at 3. So that's going to be at, let's add our, so this is going to be 1, 2, 3, and this is going to be -1, -2, -3. Okay, so now let's plot our points. And so this is going to be here, and then it's going to alternate. So the next one is going to be down here, -3. And then over here, it's going to be down here, -3. And then it's going to be up here, +3. And again, I only have to do 1 period, right? So 1 period would just be here, here, or here, right? But let's just fill it in. Oh, wait a minute. I forgot. This is reflected. I totally forgot. So this is reflected, which means this is the way it would normally be if this was 3, right? But since it's negative, it flips it. So actually, I need to change these. So again, always double check your work. So again, make sure you always double check to make sure you wrote down everything so you don't, so you catch your mistakes. So then this is going to go here, and this is going to go here. Okay, so I'm going to erase these. And so what it should look like is this. Like that. Now that looks correct. So again, always make sure that you write down the information so that you double check, and don't forget that this is reflected across the x-axis. So the way I did it first was just the way I think about it as far as thinking of a sine curve, right? But since this is negative, then I realized that, hey, this is reflected across the x-axis, so that's what I did. So I ended up reflecting and switching these. And so now that is the correct result. Have a great day.